Alright, let's go and take a look at the review for this chapter. Number 1 and 2 say determine whether the function is even, odd, or neither. So number 1, they give us this function of negative 4x squared plus 2. What we have to do to determine if it's even, odd, or neither is to plug in a negative x for this x. So we would get negative 4 times negative x squared plus 2. Negative x squared is the same thing as negative x times negative x, which is positive x squared. So this becomes negative 4x squared plus 2. And notice that between this function, which was the original function, and this new function, the signs stay the same. So when the signs stay the same, it's even. Okay. Another way to look at this is just look at the exponents attached to any x, and if they're all even, then it's an even function. Okay, let's go and take a look at number 2. Negative 3x squared minus 7x minus 1. Okay, so notice that, first of all, one has a even exponent and one has a odd exponent. So because they're a mix of even and odd exponents, we know that the answer is going to be neither. Okay, but if we plug in a negative x for the x's in this function, okay, negative x times negative x is positive x squared, so this would be negative 3x squared. Negative 7 times negative x is positive 7x and minus 1. Okay, so if we look at the original function, which is this one, and the new function, which is this one, we see that this sign stays the same, this sign changes, and this sign stays the same. So because some signs change, but some stay the same, we're going to say that this is neither, right? So again, just look at the exponents attached to the variables of the x's, and notice that some are even and some are odd, so it's neither. Okay, let's go and take a look at number 3. They give us a function f of x equals x minus 1 squared minus 5. And they give us a new function, or another function, g of x, which is f of x plus 2. So notice that the plus 2 is inside of the parentheses, and they're saying change f of x by adding 2 inside of the parentheses. So we're going to take this function of f of x, we're going to add 2 inside of the parentheses. So basically we're just combining them, and we're combining it in the way that they want us to. So adding 2 inside of the parentheses is what they have. Let's say that it was like plus 5 on the outside, then we would have added 5 over here, but that's not what we have, so let's not deal with that right now. Okay, so they're saying change f of x by adding 2 inside of the parentheses. So we're going to change f of x by adding 2 inside of the parentheses. X minus 1 plus 2, so negative 1 plus 2 is plus 1, so x plus 1 squared minus 5. Okay, so just by looking at this, we know that this is going to go left by 5 in the form of x minus h. This is technically x minus negative 1, so h is negative 1, which means that we're going to go left by 1. Okay, and then this is down by 5. Okay, so if we know that this was left by 1 and down by 5, we're going to look for a graph that moves our function left by 1 and down by 5. So our vertex should be here at negative 1, negative 5. This is something that looks like that. Okay. All right, let's go and take a look at number 4. Okay, so number 4 says find the zeros. So anytime it says find the zeros, all we got to do is set the function equal to 0. So negative 4, x minus 2, x minus 6. So right now it says f of x equals this. So what we're going to do to find the zeros is we're going to set f of x as 0 equal to negative 4, x minus 2, x minus 6, And anytime that we see an x, we're going to set that part equal to 0. So x minus 2 equals to 0. And x minus 6 equals to 0. So if we add 2 to the other side, we get x equals 2. And if we add 6 to the other side, we get x equals 6. All right, let's go and take a look at number 5. Okay. Number 5 says write a quadratic in standard form for the given condition. And a quadratic is just something to the second power, like ax squared plus bx plus c, right? That's a quadratic. And standard form means from exponents going from highest to lowest. So if the right in standard form based on the condition, and let's say the condition is that the vertex is -1, negative 25. Okay, so we know that because they're asking for a vertex, we're going to use our vertex form, which is a times x minus h squared plus k, where h and k are in the vertex. So h is the x value of the vertex and k is the y value of the vertex. In this question, we can just assume that a is 1. There will be a case where we can't assume that a is 1, but in this case, we can assume that a is 1. X minus h is -1 squared plus k is minus 25. Okay, so -1, this becomes x plus 1. Right now, this 1, we can hide it, so we don't need to write it again. Okay, x plus 1 squared is the same thing as x plus 1 times x plus 1. And then minus 25 on the end, right? Stays. We can FOIL this as x squared. X times 1 is plus 1x. 1 times x is plus 1x. 1 times 1 is 1. And then minus 25 on the end. Okay, so x plus x, so 1x plus 1x is 2x. So we'll have x squared plus 2x plus, and then 1 minus 25 is minus 24. Okay, negative 24. So we did 3 things. We plugged in our h and our k. We had to write it like this, so it's not minus -1, it's x plus 1. And then we FOIL this, and then we simplify once we FOILed it out. Okay, let's see number 6, which says the x-intercepts are -1 and -5. Okay, so we have something called the intercept form, which is f of x equals a times x minus p times x minus q. All right, so p is -1, right? And q is -5. Right, q is -5. So in here, we can assume that a is 1 in this problem. X minus p. So x minus, and then write again that p is -1, so you're going to have to write x minus -1. Don't just write x minus 1, because we know that p was -1, so we're going to have 2 negative signs. Okay, and then x minus q. So x minus q is -5. Okay, so then again, x minus -1, this becomes x plus 1, double negative, and then x plus 5. Okay, so then FOILing this out, we get x times x, which is x squared. X times 5, which is plus 5x. 1 times x, which is plus 1x. And then 1 times 5, which is 5. Okay, so our function should say x squared. We can combine these two as 6x plus 5.